We built a robot that can clear away snow. Look at the different ways people use to clear snow, whether push it away or use a snowblower, and without a power broom would be effective and also safe. Right now it works pretty well, and we haven't tested it on real snow, but on polypropylene flakes.
They're dynamically similar because polypropylene flakes have approximately the same density as real freshly fallen snowflakes. Most of our parts from Servo City, and then when off-the-shelf parts were not useful anymore, we started manufacturing our parts from sheet metal. It's a very, very fast prototype.
My name is Brian Cusack, and I teach mechatronics, where electrical engineering, mechanical engineering, computer science all come together. We don't use Arduinos and pre-built boards. These students brainstormed their robots, designed them in a week or two, put everything into computer-aided design software, fabricated everything, assembled, and then implemented electronics, raw microcontrollers, raw sensors. So the concept of Sumo robotics is that small autonomous robots, so no remote control, no outside interference, enter a ring and try to push the other one out of the ring. The robots sense the edge of the ring with an infrared sensor. It's an infrared phototransistor, and the students have to take that signal from that sensor, translate it in their logic with an analog to digital converter, and then they program the robots to interpret that sensor data and make a decision. In this case, avoid the edge of the ring.
Working together was actually really easy. The most difficult part was getting our infrared sensors to work. So the way that the robot works is we have two infrared sensors here, and that's what senses the difference between white and black, but they're also very finicky, because you need to be able to change the brightness of the LED, and you also need to be able to change the threshold at the same time in order to tune the robot. And so that's why we implemented this perf board on top, which has 4 potentiometers to control those features of the infrared sensors.
So the rules of the competition are the robots may be only 5 pounds or less, small, 10 inches by 10 inches by 6 inches, and may cost no more than $200. And with that, there's some technical limitations as well. I limit what kind of motors and batteries to use, but for the most part, it's up to them to design the robot.
The goal of the competition is to push other competitors out.
We chose giant wheels with the high coefficient of friction, so that we're hoping that we'll have a lot of torque, and that will give us a lot of pushing power to push other robots out of the ring.
There's always a lot of improvements to be made, and you always have to be ready to make those improvements. So there are a lot of factors that we didn't expect to happen. It was very important to be dynamic in our design.
And while there's a tremendous amount of technical content of the class, computer architecture, digital logic design, one of the biggest lessons I try to get across is the project management side and educating engineers to do what they're going to go on and do in industry later, which is be leaders. They write all of their code either in assembly or in the C programming language, because they're going to go on and stand on the shoulders of giants later on in their careers. I want to show them the foundation that those giants are built upon. These robots are entirely autonomous. There is no remote control, as you'll probably witness. Ready, set, go. Get him. Oh. Get him, take it.
We designed the teeth specifically in order to hit other robots off at an angle so we can catch them by the corner and push them out easily. But another thing we focused on was just the basics of making our motors run whenever we wanted them to. You can see how our robot was maneuvering through the mat very swiftly. I think that ultimately led to the success of the robot.
Nearly every robot worked. Couple technical glitches at the end, but they all worked phenomenally well, and I'm super happy with everyone.